Now the next speaker, Dr. Sanjiv Bachal, Vice President of Technology, Equinox Software Services. He is going to make presentation on simulation technology application for sugar and allied industry. Okay, the time limit is about 30 minutes, 20 minutes presentation, to 5-10 minutes interaction. Okay, okay. This is brief resume of the speaker. He has been associated with the chemical process industry for the last 25 years in the field of process and product development. He is in the process development and technical services team of Reliance Silicones. His years at IIT Bombay, CAD Center and at SABIC R&T brought at the expertise of some of the leading simulator technologies. SABIC means SABIC and Mobil are the giant American petrochemical companies in the Arabian countries, Saudi Arabia. As industry business consultant at Aspen Tech, Sanjiv has mandated to popularize commercial simulation technologies in specialized chemical industry sectors such as fine chemical, polymers, etc. He has conducted a number of training programs for many companies, both nationally and internationally, on use of various simulation technologies. He was graduated from LIT Nagpur in 1985 in chemical engineering and subsequently completed his MTech and PhD program from IIT Bombay 1995. This is very presume. I request the speaker to continue.
Thank you. So I have about 25 minutes to present, so maybe we can start. Okay, good afternoon. I think the dignitaries on the table and the present crowd from sugar industry. As Shrikant was mentioning, there was a lot of efforts when I was in the earlier simulation companies wherein we were trying to get into sugar industry, but well, as there were like, I could see that a lot of debates started now that whether we are ready or not ready and all. But then again, there are challenges, as I said, bringing the simulation technology into the sugar industry. So maybe like what I'll be like quickly going through or other presenting some of our experiences, not exactly in the sugar but the allied industry like the ethanol process. So maybe can move to the next slide, please. Yeah, you can. Okay, but this is a PDF file. Okay.
You want to click next pointer is there?
Yeah. Okay, quickly, maybe like we have been talking a lot of things about the sugar industry. I'll just briefly touch upon the sugar, like, because this was again time and again where all we can use the so-called commercial simulators, which are already there. I think earlier speaker they did talk about something which was customized, like the MATLAB based simulators, and maybe the Excel also is a simulator. Excel based model also is a simulator. But then again, there's more from the commercial one which are available off the shelf. So then again, how they are to be applied. So maybe I'll quickly go to the introduction. So these are the some of the we can say the unit, broadly speaking, the unit operations which are there in the sugar industry, wherein raw material handling. Now again, there are certain things like challenges which are there. For example, there is a multi-phase. Like we have a lot of liquid solids being handled, and time and again traditional software, so-called simulators, commercial simulators, they were not able to really use it. But of late, there are a lot of new updates which have come in, which can actually handle a lot of the materials. For example, crushing, filtration, so and so forth. Then again, all these are the processes where we can apply the technology, the simulation technology which is there off the shelf. Again, I have just focused more on what all is that for example, the ethanol process, which I'll be more talking about, is like a utilization of the product. So where I'll be like more talking about how we have used it and all. But then again, energy management, wastewater treatment, quality control, so and so forth. All these are like, for example, nowadays the simulators directly give out information about your CO2 footprint. So you do a simulation, build your process model on a simulator, and it will give you not only the heat and mass balance, but also the CO2 footprint of the complete process which is getting developed. So these are all like some of the aspects related to the sugar industry. Now, so-called, like we talk a lot of, because here again right now what we are talking about is more of the simulators which are available in the market. So what all we can do. So for example, the heat and mass balance, what the focus topic of this seminar is heat and mass balance. That is the primary goal of the simulators. But not only that. Now thing is that you are able to extend your heat and mass balances into more detailed engineering of the process. For example, you can develop your model, the heat and mass balance, and then you can focus on, for example, for heat exchangers are there. So do a simple heat exchanger design versus a rigorous one, wherein you can generate data sheets which can be directly given to the so-called detail engineer or the vendor itself, the heat exchanger vendor itself. That kind of processor are there. That too through one gateway, one simulator, wherein you do the main heat and mass balance and you do the subsequent activity. Distillation is another thing which is very much there. Rightly said, sugar, it's not directly related to sugar. Fortunately, sugar industry doesn't have any mass transfer as such, except for the crystallizer. But the allied industry, like ethanol process, downstream process, you have a lot of mass transfer equipments which are there. The distillation which is there. Now, simulators are like the most, like very powerful tools which can handle it very well. Development of your not only like modeling or like designing the columns, but then getting some detailed analysis of it, the flooding part of it, so the traffic part of it, so so and so forth, that kind. Then there are also like nowadays, for example, I could understand that there are a lot of energy related concerns in sugar industry. For example, pinch analysis. There is a water pinch also which is there. Classically, it was like water pinch. I remember like good old days, like 80s, 90s, this technology is there. Water pinch they talk about, how to like really reutilize your water. And I understand sugar industry, it's almost 89% water which is getting handled. I'm talking about only from the sugarcane juice. So that kind of, plus the processed water, what is being used, that's different. So all this water, with considering the present scenario, the present pressures on the water availability. So water pinch is also some of the things which can be used for sugar industry here. And then again, the steady state part, HNMB, but then this steady state can be extended. I think one of the thought which was shared was we should have dynamic model. Obviously, dynamic model is important. So the starting point for any dynamic model is a steady state model, the steady state heat and mass balance. So once you develop that, you can go and develop the dynamic, which is also very useful. We have, I'll share the work which we have done for the ethanol industry in relation to the dynamic industry. So there are like a lot of things which we can do using the dynamic model, and it has got its own utility and its own utility and its power for the industry. Like I said, our exercise was more in the ethanol process side. So I'll be like quickly talking about what exactly was done in this particular process. Like we use certain simulators, the kind of activity which we have done, and where the customer could get value out of it, the value part of it, and the so-called simulation work which we have done for the particular process. So this we are more of focusing on the ethanol, wherein we have used number of packages related. For example, to share with you, when we are starting a design, we can also do some kind of capital cost estimation right at the HNMV level. So when you do a rigorous heat and mass balance with the simulators, you have technologies which we can go and do so you get a preliminary cost estimates for your plant, which is likely to be there, a very good estimate, capital as well as operating cost. Like I said, the dynamic model for it, and then I think benefits, some of the things I'll just skip and then move on to the actual case which we have handled. So I think maybe a little bit here. So these are the some of the benefits we are talking about. Like I said, the rigorous heat and mass balance, which we call it the steady state model, which gives it can be used as a real-time optimizer. There is something like applications which we are talking about the digital twin. So as I said, we time and again we keep on telling, the moment you develop a certain model, it becomes asset for that organization. Now this asset is utilized at different point of time. So for example, at the design stage itself, there's something which is developed, and after design, when the operation or really the plant is set up, the same model can be utilized in number of ways. So one thing is assessing the performance in future time and again, like what earlier Alok shared, when the information is coming from the plant in the real time basis, you use the same model, modify a little bit, and then you keep on cross checking with the design. So the design part which we are talking about is already there in your as a digital twin or digital virtual plant we used to call it earlier. So that virtual plant is already there, and you can keep on comparing your present operation, and then get information, or like try to find out where the things are going wrong, or where is the bottleneck, and then de-bottleneck accordingly. So it becomes an asset for the organization. That's why many times, like for example, in this case, the thought was like start the design with a simulation model itself. So that is what has been done here. And also a dynamic model, which again the purpose here was like to train the so-called likely staff which will be there. So nowadays, like this again, something which is very common in so-called refinery or petrochemical industry, wherein when the design is started, when the plant is, they start the design of plant itself, parallelly there are models are created. The dynamic models are created, which are used for creation of OTS, what they call it, operator training simulators. Now the idea being like before the plant is done, when the plant is started commissioning, the staff which is going to man it gets trained on it. The idea being like they are exposed to the actualities or what the how the plant is going to be operated, the startup, the shutdown, any kind of safety related issues which are likely to be address them there and there itself. So this is the starting point nowadays, which has been followed in many of the matured, like in the sense simulator matured industry like refining and petrochemical, where again this is also what in this case we have tried to or rather we have made this model from that standpoint. The plant is being designed, parallelly you also design a OTS, so that when the plant becomes is getting commissioned, the people who are going to man it, they are trained to it. So that's what like. So this was a plant which was having capacity of 120 kiloliter per day, built somewhere for like to be coming in the central India. It was, as I said, executed in 2 phases. So this first phase was like getting the again here there was some information coming from the existing plant. There was a plant which is already there, and this is supposed to be a scale up or using that data built up a new model. So there was like one thing is like building of the model, and then initial phase validating with the data which is already there with the which has come with the operation of the earlier plant. So the design activity was first validating, so that the one of the issues which is related to the accuracy of your model is getting validated. Once your validated model is there, then you do a scale up on that. So then again, I think one of the point which was raised, how to ensure that your plant is really or the simulation is really replicating your plant. It's a real digital twin or virtual plant of your system. So it's like you getting the real data from the plant, and then there are ways and means of doing it. The simulators now have very advanced methodology and techniques or built-in functionalities, wherein you can change the properties of interaction properties of different components which are there, and then keep on improving the so-called performance or rather the accuracy of model. So that's again possible. So here again the idea was like the data was there from a smaller plant. You build the plant, you sort of validate your properties, and then you get to the next stage of the scaling up. Now not just the scaling up is like for the turn down and turn up for the 120 plus minus whatever capacity, and then it has to be validated for whether the system which is the so-called the columns which are there, are they going to perform or not, or what kind of margins to be kept. So that kind of things were taken care of it. Then again, this the first stage of the so-called model part of it, the heat and mass balance, rigorous heat and mass balance. Then you move on to detailed design of heat exchange, because again it doesn't stop there. The complete activity is like each and every exchanger of the system was modeled in detail, and obviously like as I said, they were like data sheets generated out of it. And then as I said, the sensitivity analysis for over and under. And the second phase was like more of development of the dynamic model. So actual dynamic model from the steady state model was created rather. And then that was like, I'll show some screenshot. Unfortunately, we had idea of showing you certain things, but then there is issue with the licenses and the thing. So I think I'll just show the screenshot. The idea was like, as I said, the training of the likely staff which is going to operate the plant, plus development of the strategy, the control strategy. So many a times what happens, like there is certain things which are not there. There is a previous experiences, but then whether it can be improved or some changes can be done so that the plant can be brought to steady state in a faster way. So that kind of thing were also tried out. Different strategies were tried out. Also the control strategy which was it okay, not okay? That also tested using the dynamic model. So there are certain things which which were done prior to like going in for fabrication itself. Like in the sense the designs are ready, the final designs are ready, and the model of the plant or the virtual model is already there in place, and it is getting tested for its performance, and also training. This is quickly that it has multiple columns for getting the final product. So this is the ethanol system we are talking about. This again, unfortunately, we are not able to show this. This is a kind of model wherein not only the main section, this I think there's a pointer here. Yeah. The last one, the middle one. Yeah. So okay, I think it's very crowded thing. So there are all the columns with all the recycles covered up. So one of the things which we are talking about, heat and mass balance, all the panes. This we have shown for ethanol, but then I think we did some exercises long time back for sugar industry as well. Heat and mass balance, but obviously they were like you could not get it across. Oh, fine. So this is all like bottom here. You can see this is the complete water cycle, water evaporation system, and so on and so forth. This is this gives a steady state balance, steady state material heat and mass balance at different capacities. And good part is we could do a calculation automation. For example, I can just change number at one place, the input number, the throughput, and my system gets calculated automatically. Everything is like taken care of. The distillation system, the purity part, I put a kind of calculator for it to do it automatically. So it's like that kind of ease of getting analyzing system, doing a sensitivity analysis that is possible with the so-called simulators here. This is something I like, as I said, not only the so-called theoretical stages calculation, but then we can also go into, like I said, the detailed analysis. But again, this again we call it pre-feed kind of activity. This goes finally to the actual vendor who will revalidate it. But then you can do a simple calculation, finding out what kind of flooding so the hydraulic calculations can be done for the actual column performance. So something like this, all this comes as a part of the development HNMB. This is, as I said, this is a heat and mass balance to start off with, and then you do all the focus part of it. This again, I was talking about the rigorous heat and energy balance, the rigorous exchanger design. So you get directly a TEMA, like this kind of TEMA data sheets, which can go directly to the fabricator. This is something like the dynamic model I was talking about. This is the dynamic in the simulator environment, and these are the. So imagine this is like the plant is not in place, but then we already have all the screens, all the DCS screens, distributed control systems, all the screens ready, which actually the operating personals are going to see when the actual DCS comes in the picture. So this is created before the actual plant has come in, and it actually operates as the main operation or main plant is going to operate. All the control system, all the safety systems in this, all the interlocks in this, which are going to be there in the final plant, are built into this, and the user sees this kind of interfaces. So he, if you, for that matter, what we say that if he's put in a room where the screens are there, and outside there is like it's close to him, so it's almost like sitting in his control room. Huh?
Please conclude.
Yeah. So this is again some of the screenshot of the actual simulators which OTS we had created, the DCS screenshots. Okay. So maybe I'll like in conclusion I'll say okay, you can reduce it. So maybe like with that I'll open the floor more for discussion, so that will be more productive. Like this is our first hand experience. Rather, it is a kind of we are very confident about other industries. Obviously, sugar industry we are equally confident that it will be very important. Like it will be useful as far as the energy part of is concerned. I think one of the thing which keeps post whatever was going on, the water pinch and the heat pinch is very important for. I don't know whether that has been some of the publication they do talk about these things, the heat integration, because essentially what I feel is sugar refine or the sugar purification is nothing but heat transfer process wherein you are almost taking out 89-90% of water. Like it's like a evaporation process. So if you look at from that perspective, it's only water separation. Even in ethanol, it's the same thing. What ultimately we are doing is we are removing a huge amount of water, and water has a very high latent heat. And that heat, if you are able to like, I was wondering, any of the earlier like some of the like sugar experts here, the typical what is the specific heat of requirement, the thermodynamic limit. We always keep on when we use simulators, we talk about what is the thermodynamic limit. That is supposed to be the one which cannot be violated. So whatever people claim, it cannot go below that. So for typical sugar industry, what is this thermodynamic standard which we should be targeting it? And then when we say a sugar plant is operating, I am maybe 90% of my thermodynamic limit. That is what is the terminology which they use for refining. So a ton of crude refined, what is that thermodynamically required heat versus what I am actually using? So am I 90% of the 100? Am I 90% to it? 95 to it? So depending on how far I am, I know what is the opportunity, and accordingly I use this technology for reducing the gap. And also I can like project my system as a not just by any arbitrary thing, but I have some standard to my, sort of compare my system, how good it is or how energy efficient it is.
Please conclude.
Yeah, I think with that we can maybe if questions are there, I would be ready to glad to address them.
Now paper is open for discussion.
Yeah, that is. I think I've taken 20 minutes, so I kept a watch.
Yeah.
So it is a topic of passion, so I can go on for quite some time. But then I think discussion is more. It should be thrown open for.
On the subject,
Yeah.
but time is short.
Yeah, exactly. Any specific we can like always maybe details we can have a discussion beyond this.
Since there is no question from the audience, it is understood that audience has understood very nicely.
Understood or not understood?
Completely. Completely.
Understood or not understood?
Two probabilities will be there. Completely understood or not understood.
Yeah. Yeah.
He wants to ask something.
Just one question here. Yeah.
Hello. Very interesting presentation. You said you did one case study in Central India of 120 case.
Yeah, this is the case study we are talking
Yeah.
about.
So, how was your experience? I mean, they were operating the plant with certain capacity, with certain inside inputs and outputs.
Yeah.
Your study, which was done on that, was objective was to evaluate or was to improve?
No, the objective was like for the new plant, the complete design is to be.
This was a new plant totally?
Yes, totally new plant.
Oh, sorry.
So what I said was the data from the old plant, smaller plant was there to validate to the model.
Yeah. So my question is that if you normally normally operate 120 KLPD normal plant,
Mhm.
and then using your inputs and your software, do you see any improvement in the total performance, or how much it is?
Unfortunately, that 120 KLPD heat and mass balance was not there.
No,
So
it
that
was not
that
there.
was not there.
So what do you mean?
So
The
we
what
had to
it was
create-
not there means
we-
what? I mean, they were using.
No, the plant, the old capacity was a smaller capacity.
Okay.
So obviously the mass balance was a smaller capacity. So if you maybe retro like sort of we can say prorate it for the higher rate, higher capacity, that would have been a linear one. So I don't know whether that is a good number to be compared with.
So my simple question is that you see we are operating 120 KLPD plant with normal softwares are available with the people.
Yes.
Like there are so many suppliers.
Yes.
Now, have you studied that, and based on that you have done energy balance calculations to improve upon, and how much is the improvement in that?
No, not on the existing one. What we have done is we have used data from the smaller plant to validate the model and build a bigger plant. So it's like a greenfield bigger plant. But using the data, because the client wanted to validate whether what we predict is able to we are able to get the same kind of qualities or not.
And my simple question, what is your opinion about the plants which we are operating now at the moment, distillery? I mean, are you happy with those performances?
Let us look at the data of 120 K.
Yes,
Yeah,
exactly,
yeah.
exactly.
So
The
another
plant-
120 KLPD
Yeah, let us
without
look
your
at-
software, and the 120
And with the
KLPD
software.
with your software.
Yes.
How do you feel? I mean, what are the best points which you can share with us?
Sanjiv, sorry.
Yeah, hello. Yeah,
I will not comment on this 120 KLPD sugar ethanol plant, but recently we finished another interesting plant which is 10,000 tons per annum of xylene. And there definitely I can say with confidence that the design achieved almost 40% reduction in energy consumption, specific energy consumption.
okay. Specific to this 120, because we did not have any comparative, like I said, the reduction in that one. So if you look at the linear, like prorating it to 120, so definitely we have got a improvement.
Okay, sir. Thank you. Thank you very much.
Okay, a nice presentation by Mr. Sanjiv Bachal.